Hey, this is Dr. B, and let's talk about the organization of the periodic table. The first thing that I think about when I look at the periodic table is that I really want to focus on the columns, not the rows, or in periodic table speak, that's the groups or families and not the periods. And really, by doing so, you just gain a lot of knowledge. All the columns tend to behave the same, right? The noble gases tend to be all inert, the group 1 metals all tend to be insanely reactive, etc. So it's really a focus on the number of valence electrons that are present. That's what they have in common. So the first column has 1 valence electron, the second has 2. These all technically have 2, but they have generally unfilled inner shells, and then valence electrons go to 3, 4, 5, 6, 7, 8. And as a result of that, the charges come out. If you have 1 extra electron, you're going to lose it. That gives you a +1 charge. 2 extras +2. Throughout here, it's uncertain due to the unfilled inner shells. They oftentimes do multiple things, always losing electrons. Third group, sometimes referred to as the 13th group. I'm just going to call it group 3. 3 valence electrons, they'll lose them all. Fourth group is more likely to share than it is to ionize, since it would have to gain or lose 4 electrons, which is energetically difficult. Now 5 valence electrons, easier to gain 3 than to lose 5, so it tends to have a -3 charge. -2, -1, and 0 following the same sort of pattern. The orbitals means really the pairs of electrons that we're dealing with, and I'm really talking about electron configuration here. 1s, 2s, 2p, 3s, 3p. In previous slides, we've gone through this in great detail. This is the Aufbau order of electron configuration. Metals are those substances, I'm sorry, we're now into blocks. The blocks include the S block, the P block, the D block, and the F block. And in the not too distant future, you can expect to see the G block begin to be populated. These are well defined in this form of the periodic table. In most other forms, you won't see these little spaces in between, but I think it's a great way to do things. So they're S, P, D, and F. Periods means rows. And in that case, it's nice and simple. That's a real hallmark of a well-designed periodic table, is that it's just first row, second row, third row, etc. And those are also the shells, first shell through the 7th shell, which is as far as it currently goes. The groups or families are the columns, and some of them have some common names, including Group 1, the alkali metals, Group 2, the alkaline earth metals, Group 7, the halogens, Group 8, the noble gases, and there they are. Fine. Just some common names. Which ones are metals? Left of the staircase. Nice to have this staircase here. Notice that there is some gray area in between, and these would be the metalloids. Most periodic tables highlight them specifically. No real perfect pattern here, and so it's just good to know that generally speaking on the staircase is a metalloid with a few underneath the staircase, if you will. Those are the nonmetals, metals, and metalloids. And there you go. So that's some organization for the periodic table.